Hi there. In this video, we're going to be talking about trigonometry. Trigonometry is a topic in mathematics where we look at triangles. Specifically, we'll be looking at the sides of these triangles, the lengths of these sides, and the relationships that these lengths have with the angles of this triangle. There are many relationships in trigonometry, so we want to focus on the main ones that you need to know. This is Z Online School. In this video, you and I are going to be answering mathematics paper 2 questions on trigonometry. By the end of this video, you will be able to solve problems by using the sine rule and the cosine rule. You will be able to solve problems involving area of non-right angled triangles. You will also be able to solve trigonometric equations and sketch graphs, for example, the sine graph. At the end of this video, we've got bonus tips for you. Make sure you watch this video till the end to get the maximum value out of it. Question we're looking at Mathematics Paper 2, 2020 GCE question 9. The diagram below shows the positions of a guava tree, orange tree, and lemon tree on a farm. You can see the diagram here and how the trees are arranged. Focus on the points, the distances, and the angles that have been given. We've been given that LG is equal to 10.1 meters, OG is equal to 14.2 meters, and the angle OLG is equal to 40 degrees. The question here asks us to calculate the following things. In the first question, we're asked to calculate angle OGL. Looking at the diagram here, you can see that the angle we're asked to calculate is the angle at G. When we see this representation here where they've given us 3 vertices, the angle we're looking for is at G. So we go to G, which is here. The angle we want to find is the angle here. Now, as we're doing trigonometry, there's a thought process that you're supposed to get used to. The first is you understanding the diagram, which is not a very difficult thing to do. The next thing you want to do is recognize which methods you're going to use to handle the question. I think you can think of 4 things. The first is look at the question and see if you're going to use the Pythagorean theorem. Are you going to use the sine rule, cosine rule, or are you going to incorporate the sum of interior angles of a triangle? These 4 things are key things you should think of when you're handling a question in trigonometry. In this question we have, how we're going to handle it. We've been asked to find the angle here. This angle here can be found if we had the side here, and we could use the 3 sides, this one, the 14.2 and the x to find that angle. Since we don't have the x here, we can't use any rule that uses this method. If you're following me, that rule should be the cosine rule. In this question, the cosine rule won't be very easy to use. You go to the sine rule. Can the sine rule help us in any way? Okay, since we have this angle here, the 40 degrees, and the side opposite it, we can easily find the angle at O. So this here is going to be our first procedure. We're going to find the angle at O. Now, after we find the angle at O, this is a triangle. So if we have 2 angles in the triangle, we can find the missing angle here. So our second step will be using the sum of interior angles of a triangle to find this angle that we want. As you can see, using that procedure will guarantee you to get the questions in trigonometry answered right. So we can start from using the sine rule. Like we said, our first step will be using the sine rule. We can use the sine rule to find the angle at O. The sine rule is written like this. Now I want you to get used not writing it in this form and just writing it directly. You can put your sides on top, your sine B below. There's no problem with that. Now, you can write it in this form and just know which angles you are replacing it. However, it would be better that you replaced these letters with the actual letters that are in the diagram. So we're going to rewrite this, having that you know the sign looks like this. Now let's rewrite this using the correct letters. Instead of saying sine A, we're going to say sine L. I would like you to start with those values that you have already. Then we want to find the angle at O, so we should involve sine of that angle somewhere. And then the opposite side to O is going to be the lowercase o. Then we need to make this bigger O the subject of the formula. Or like most people would do, they'll just insert these values that we have. At L, we've got the angle 40. And the side opposite 40 degrees is 14.2. Then we've got sine O here. The side opposite to the angle at O is 10.1. Then we can cross multiply since we put fractions on both sides and then see where we get. This here is going to give us 14.2 sine O is equal to 10.1 multiplied by sine 40. Notice we've got a 14.2 multiplied with the sine O. Here we can divide both sides by 14.2. Obviously on this side, this 14.2 is going to cancel out. And then this side we're going to have 14.2 since we divided both sides by 14.2. And then work out this and find its value and equate it to sine O. Sine O is going to be equal to, and then we multiply that by sine 40. We can even do it directly just like this. Sine 40, close that bracket there. We hit equals, then divide this by 14.2. So that's our value. So we had 0.45719. Can continue going to the 4, but we're just going to show we had an answer that is like this. Then find the value of O by finding sine inverse of what is on the right side. You can keep going with your values, there's no problem, but our value is already on our calculator, so we're just going to find sine inverse of what is on our calculator and have the accurate answer of O. Okay, now we just find sine inverse, the second function of the sine button, and we had our already stored answer on our calculator here, so we just say sine inverse of the answer and we hit equals. So our angle is 27.2. The angle at O is 27.2. We can get a lot more values than just the 2 there, since this is not our final answer. So we found the angle at O. You can remember in our diagram there, we said we're going to find the angle at O, then use the concept of the sum of interior angles of a triangle to find the angle at G. So now we know that we're going to use the sum of interior angles. So we have the angle GLO add it to the angle LOG, and the angle that we want, OGL, we're going to have 180 degrees. So if we make OGL the subject, meaning these two angles here cross over to the right side and become negative, we're going to find the angle OGL. So the angle OGL is going to be equal to 180 minus the angle GLO minus the angle LOG. And notice the angle LOG is the one we're just from finding here, this one above here. So if we substitute the values of the angles here we're going to have a 40, and the LOG we're going to have the 27 there. The answer we're going to get here is OGL. So the angle OGL is equal to 112.79. The answer we're going to write here is going to be correct to 1 decimal place. That's what instructions or the information given to the candidate says on the first page of the examination paper. So it will be 112.8 degrees. This is our final answer. The next question asks us to find the area of the triangle OGL. Notice in trigonometry, area of a triangle is given by the formula half AB sine C. From this formula, what you want to get is whenever you want to find the area of a triangle in trigonometry, you should have two sides and the angle between those two sides. From the calculations that we've just done here, in our triangle that we have, triangle OGL, we've got G here, we've got L and O. We've got A and B, and we've got the angle between them, which can be noted by C. So it's very possible that we can find the area of this triangle because we have the two sides, A, B, and the angle between them, which is C. However, we're not going to use these letters A, B, C. We want to use the letters that we have been given. We've got L here, we've got O, and we've got the angle here, which will be represented by G. Therefore, area is equal to half LO sine G. We get the distance L, which we have 14.2. We get the distance O, 10.1. And then we get sine of the angle between these two distances or these two sides. That angle we're just from finding is 112. It would be better if you didn't use the rounded off answer here. 7,938.1. Remember, there's a half, so we can get this whole thing and divide by 2. And then the answer we get is our area. We have our angle there, so we can just say sine the answer so that we can simplify things, meaning we've worked out the sine, the angle there, then we multiply by 10.1 and multiply by 14.2. We have our answer, then divide by 2. So this is our area. This area should have units. Don't forget about the units. The answer here is going to be correct to 3 significant figures Our distances in the diagram are given in meters. Therefore, the units for the area of this triangle will be square meters. Our answer here is going to be 66.1 square meters. In the third question, we are asked to find the shortest distance from L to OG. We have a triangle in this case, which is triangle OGL. We've got O there, we've got G, we've got L. If we're given a height should be at 90 degrees with the base. When we get this base here, let's say this is LO and we have this particular height, when we use the formula area is equal to half BH, what we're going to get is the area that we just found. It was like 66.1, right? So if we get the base LO and a certain height H, we're going to use this formula and find the area which we just found. If we do the same, instead of using this height, we get a different height. Let's say a height from the vertex L that comes here to meet. So that can be done better. It should be at 90 degrees. This height here we're going to get, and the base of this, the length OG. If we multiply them using this formula and divide by 2, the answer we're going to get is the area. So one thing you want to realize in trigonometry when they ask you to find the shortest distance is that they're just asking you to find the height from a certain side of the triangle that is going to give you the area that we just found. We're using the always common formula for area of a triangle. A is equal to half BH. The H here, like we said, is the shortest distance. And now what you have to recognize is the base we're using. The base is just this side they've given us. They've told us the shortest distance from L to OG. If you look at OG and we put it as our base, we can easily find H. 14.2. And we have our H like that. Our area here, we can use the 66.1098. Just gotten more values from our answer. And then we can work out the answer. This is a good way of working this question out. There's no problem. What you just are going to do here is put a 1 there. Cross multiply. The 2 is going to multiply with the 66. In this side, you can see we've got a 1 there and there's a 1, so we're just going to have 14.2h. And we can find the value of h by just dividing both sides of this equation by 14.2. This 14.2 here will cancel out and we're just going to have the value of h. Since we've cancelled out the 14.2, we're just going to have h if we work out what's on our left side here. Now, before we calculate the h, what I want you to note is that instead of always doing this process of plugging in your numbers, multiplying until you get h, you can just always remember that after you make h the subject of the formula here, you're going to have 2a over b. So whenever you're asked to find the shortest distance, just remember this simple formula. H is equal to 2a over b. If you don't want to remember the formula, then just plug in your numbers and find h. But it's one and the same thing. So we're going to get 2 and multiply it with our earlier answer. As you can see, there's a 2 here multiplied by 66.1098. Our answer has more values, so our answer if we use that more accurate value, we will be more accurate. So 2 multiplied by the earlier answer for the area that we calculated. When it equals, then we're going to divide it by 14.2. This is the shortest distance from L to OG, 9.31. We're going to write it to 3 significant figures, so it's going to be 9.31. Remember to add your units there, they are very important in this case. In part B, we've been given a trigonometric equation. We've got the left part with a trigonometric function that is equal to the right part with just a number. We've also been given a restriction here. The value of theta is supposed to be between 0 degrees and 180. The first thing here that you want to do is remember the information about the quadrants. You can just make this simple x or y plane and remember how and which functions are positive in which quadrants. You should always remember in the first quadrant it's O. An easy way is just remembering the word cast. Then we start writing this word from the fourth quadrant. We have the A there, the S, the T. Apart from that, there are many other simple phrases that you can use. For example, all students take calculus can be an easy way of also remembering how the trigonometric functions change in sign in each quadrant. Well, we've got A here, it means all the trigonometric functions are positive here. S means sine, T means tan, C means cosine. The next thing you want to know is the relationship of the angle in the first quadrant here. If we have an angle theta in the first quadrant, we can represent the same angle in the second quadrant if we just apply a certain change to the value of that angle. For an angle in the first quadrant, theta, to become an angle in the second quadrant, we're just going to find the value of 180 minus the theta that we had. In the third quadrant, we're just going to find the value of 180 plus theta, which is the angle in the first quadrant. In the fourth quadrant, we're going to find 360 minus theta, theta being still the angle that was there in the first quadrant. This information should be on your fingertips when you're looking at trigonometric equations. The next thing you want to do here after you've remembered which trigonometric functions are positive in which quadrant is obviously knowing the angles here, which I've got to indicate. Here there's a 0 degrees, there's a 90 degrees, there's a 180 here, and there's a 270 degrees. If you come back here, you have a 360. So now, in this question, you've seen the restriction they've given us. The angle theta that we're supposed to find, or the angles theta that are going to be our solution, should only be angles between 0 and 180. Now, one thing that you can point out from this question is that our answer will be kind of very interesting, because as you can see, cosine here is only positive in the first quadrant and the fourth quadrant. However, the angles between 0 and 180 degrees, not all of them are going to have a cosine value that is positive. Anyway, let's get working and then I'll try to show you what I've just kind of explained. The first thing for a trigonometric equation is writing it down. After we've written it down, we want to get the cosine theta on one side. So we try to get rid of everything that is with the cosine theta here. There's a 5 there, so we're going to divide both sides by 5. And then we're just left with cosine theta is equal to 3 over 5. Now to find the value of theta, we've worked with trigonometric equations, I'm sure, for a long time now, as you are revising for grade 12. We're just going to find cos inverse of our fraction here, 3 over 5. And let's find the value of this simple calculation using our calculator. So we have the second function, of course, which is cosine inverse. Then instead of finding the value of 3 divided by 3, we can enter this fraction directly as it is. On this calculator, it's this button here, and for most calculators, it's this button. So try to check the button here, which is in the second row, just the first one. There should be something that brings something a bit similar with this here. For other calculators, it won't give you a display like this where it looks like a fraction. It will look like what I've just shown you on screen here. But for this one, it looks like a fraction. 53.13 is the value of theta. Having that we just want answers for angles to be correct to 1 decimal place, 53.1 degrees is fine. This is our final answer. Now, you might be asking yourself, why haven't we found the other angle that will also give us a correct answer? Well, if we look at this question that we have here, we can start from this step here. The value of theta here is supposed to give us a positive value when we find the cosine of that angle. When we come back to our quadrants here and the information that they give us, we know that if we have a certain angle in the first quadrant, the only positive value of that angle, apart from the one in the first quadrant, is going to be the one in the fourth quadrant. If you look at the angle that will be in the fourth quadrant, you will find that that angle is going to be past this restriction that we've been given. They've told us the angle theta is supposed to be between 0 and 180 degrees. If you find cosine of that angle, it should give us 3. Now, I would like us to just do this practically with the calculator so that you see how everything works out. I believe it will make even much more sense. You can see the answer we have here. It's 53.13 and there are other values. So we're going to find 5 cosine this angle here and see if it's going to give us a 3. 5 cosine the angle that we had, which is our answer, and then hit equals. You can see it gives us a 3, right? Now, the other angle that can give us the number 3, it's not going to give us 3, it's going to have a negative. Is the answer if we get this 53 here, 53.130, and then we manipulate it to become angle in the second quadrant. That can give us the number 3, but it will be negative, because if we look at our information here on the quadrants, we know that we can get theta in the second quadrant, but it's not going to give us a positive value because cosine in the second quadrant is going to be negative. We can still have the number 3 or the magnitude of 3, but it's going to be negative. Notice our trigonometric function here, cosine theta is equal to a positive value, so we don't want a negative value. But yes, we can find a number that will give us 3, and we can prove that using our calculator. Let's just find our very accurate answer here. Let's start from cosine inverse 3/5. Okay, then we can subtract that answer from 180. So this is 53.13 and those other numbers in the second quadrant. So if we find 5 cosine this angle that we've just found, you're going to see the answer is -3 this time. And because it's -3 and not +3, this is not a suitable answer. It still has 3, but because of that negative, it means cosine theta here is not equal to this 3/5. So the answer in this case is just the 53.13, because there's only one angle, 53.1, which is able to give us a +3. If we find 5 cosine 53.1, the answer will be very close to 3. As you can see, there is 3.00, but if we use the very accurate answer, we can get just the value 3. If we find the angle in the second quadrant, but it's still 53.1, we're not going to have a 3, a +3. We're going to have a -3. And because it's -3 and not 3, that's not a suitable answer. However, you will see that if we get this 53 in the fourth quadrant, 360 minus 53.1, that's how we can get that angle in the fourth quadrant. Notice that if we find 5 cosine that angle, which was 306.9, you're going to see that it's going to give us 3. Why? Because cosine in the fourth quadrant is positive. So the main point here is that you should understand your quadrants and how they are related to each other. If you don't understand that, questions about trigonometric equations might become very difficult. If everything about trigonometric equations does not make sense, be sure to watch our video that explains trigonometric equations further than just this. The next question comes from Mathematics Paper 2 2019, question 8. In the triangle ABC below, AC is 275 kilometers, angle BAC is equal to 125 degrees, and the angle ACB is equal to 40 degrees. In the first question, we're asked to calculate the distance BC. This is the distance here we're calculating. You can see that that distance is opposite 125. What you want to do here is ask yourself those 4 questions. Am I using the Pythagorean theorem, sine rule, cosine rule, or the sum of interior angles of a triangle? As you can see from this question, we've been given 40 degrees here. We've been given 275 here, but notice we don't have the angle that is opposite to this side. So the first thing is finding this angle. When we find that angle, then we can use this 125 to find the side here. So our first step is finding the angle here, then using the sine rule to find the side BC, or the distance BC. So what you see in trigonometry is that it's not only about knowing your rules, you also need to know some simple properties about the triangle. So using the sum of interior angles, we know that if we add angle BAC, we also add angle ACB, then we add the remaining angle CBA, which we want to find, we're going to have 180. So we're going to make angle CBA the subject. And making angle CBA the subject, what it means is we're going to have 180 degrees minus the angle BAC minus the angle ACB. Notice in our question we've been given these 2 angles. So the angle CBA, which we want, the angle at B, is going to be 180 minus BAC, which is 125, minus 40. If we find the value of this, then we have the angle CBA. So the angle at B is 15 degrees. This is not our final answer. However, it leads us to finding our final answer. Our first step was using the sum of interior angles to find the angle at B. Then we can use the sine rule. So now we're going to use the sine rule to find the distance BC. We know what the sine rule is. Sine A over A is equal to sine B over B. What I want you to do is look at the diagram. We're going to be using the angle at A, and we're going to be using the angle at B. So sine A over the side opposite angle A, then sine B over B. We have the distance B, we have the angle at B, and we have the angle at A. So finding A is very simple. When finding A, since these two sides of the equal sign are both fractions and they are related by multiplication, we can easily swap the diagonal parts of this equation. So we can swap this b and this sign a, meaning this b can be on top of this a and this sign a can come below here. Nothing changes. So that's what we're going to do. Sign b here will come where there was an a over sign b, which is equal to a over b. These changes do not change the equation. Then we're going to make a the subject of the formula, which is something very simple. We cross multiply, but since we've already put a as a numerator, we can just get this b and multiply it by the sign a. So a being the subject of the formula is just going to be b sin a over sin b. These simple manipulations of your equations can make you sometimes even be a bit faster when you're working out questions in mathematics. So get used to doing certain things like this. When you see fractions like this and you want to make a certain letter the subject and it's the denominator, you can easily just swap the diagonals. I just swapped the a and the sign b like that. It became this, and then just multiplied this denominator with the numerator. Because even when you make the subject a, you're still going to have this expression. Now what we do is just substitute. In place of b, we're going to put the actual value that's supposed to be there, which is 275. Sin a, the angle at a is 125. If you want, you can put some brackets there to just know it's an angle. Sin b is the value of b is the angle at b, which we found as 15. And therefore a here is going to be, you can start with the numerator there, 275 sin 125. Then we divide by sin 15. Notice I put sin 15 in brackets. These brackets here. Okay, so the distance is 870.36. Going to round off using these three, nothing is going to change. The main thing here is we want to leave our answer correct with three significant figures. Okay, so our answer is going to be 870 kilometers. And this is three significant figures. The next question in this past paper is finding the area of the triangle ABC. Like I said, you ask yourself one simple question: do I have two sides and the angle between them? Of course we do. After we calculated the distance BC in our triangle, you can see that we've got two sides, the side AC and the side BC, and then we also have the angle between side AC and side BC, which is 40 degrees. Therefore, we can use the formula for area of a triangle in trigonometry, which is half AB sine C. What you want to do here is check for the letters in the question if they are matching with this formula. Okay, so yeah, they are matching here, so we can just write it as AB sine C. There are not much changes here. Side A is the side opposite the angle at A, which is the number we just found here, 870. We can make this answer more accurate by adding more values. Then we've got B. B is 275. And then C, or the angle at C, is 40. Actually, we have our answer on our calculator, so we can just get it as it is, multiply it by 275, and find sine 40, then divide it by 2. This is the area, 76,925.7 square kilometers. I think we can end on 7 like that, and then round this off to 3 significant figures. I think we can round off using the 2, which will change nothing. So we have 76,900. And don't forget the units, it's square kilometers. Rounding off your answers here looks like it's nothing important, but it becomes very important when exams are being marked. What I want to show you before we go to the next question is how you getting a value like 870 here will change your answer. And then I want you to notice how rounding off your answer will save you from getting this question wrong. If I have 870, the rounded off answer of my distance BC, I multiply it by 275, and then sine 40 there. I divide it by 2. I want you to notice how different this answer I've gotten is from the answer that we had. This one is 76,893.4. Now, if you look at this answer that I have, and I round it off to 3 significant figures, it means I'll be rounding off with a 9. After rounding off this answer, you can see that I still have 76,900 square kilometers. And so it's a very good practice to follow your instructions. If you don't follow them, they might cost you sometimes, because your examiners might be using exact answers, and when you give them this 76,893, they might think this is not the answer. But when you round it off to 3 significant figures, you can see it brings us back to the same answer that I just had. So always remember to follow that instruction. The next question here asks us to find the shortest distance from A to BC. We should recognize that when they tell us the shortest distance from A to BC, they are telling us that our base is going to be the side BC. After recognizing that, you should always remember that in any triangle, this formula can be used to find the area. Some of you might say, but no, sometimes it doesn't work. Yes, it doesn't work if you don't have the height. If you've got a triangle like that, obviously in this triangle we've been given some sides and the like, but yeah, let's just say we had an arbitrary triangle ABC like that. If I get a distance like this distance here is not at 90 degrees. So if I get BC and multiply by this distance, let's say X, I'm not going to have the area of this triangle. But immediately, I don't use this distance here, but I get one distance that is perpendicular to the base and touches that vertex. This distance here is called the height. And when I get the base and multiply by that height, using this formula, I'm going to get the area. Like I explained some minutes ago, this formula works whenever you have the base and the height. And when they tell you to find the shortest distance, what they're asking you is find the height when the side BC is used as the base. And hence what we're going to do is just make H the subject. And if you've been following along, H is equal to 2A divided by B. What is our area? We just found our area. We can use 76, the one we found, 76,925.7, I think. Yeah, 25.7. Our base is side BC, which we also calculated earlier. If you can remember, the value was 870. We can use 364. Notice I'm using the values that are not rounded off that I found. Then I punch this into a calculator and find the value, and I am going to have the shortest distance from A to BC. Okay, this time I'm not going to use any values on my calculator. That one was for what I was trying to explain. So I'm just going to get the ones here, 76925.7, hit equals, get that value, then divide it by 870.364. 176.7667 is my value. I think we can round it off to maybe the second decimal place just to show the examiner what we had. But the idea here is to get our answer to 3 significant figures, and that will be 177. And this should be in kilometers. And when I round off my answer, it's always a good thing to show how I rounded it off. It's to 3 significant figures. You can add this statement always when you don't show your answer that wasn't rounded off. But the best thing is you showing that answer that you didn't round off, then writing your rounded off answer. It will always save you from making mistakes. The next question is a trigonometric equation. We've been told to solve equation 13 cos theta is equal to 5, where our answer for theta is supposed to be between 360 and 0 degrees, or 0 degrees and 360. What you should remember is what I earlier said about your quadrants. The first thing is know which quadrants cosine is positive. We are finding the value for which cosine is positive because in this question that we've been given, we've been told 13 cos theta is equal to 5. And so if we make cos theta the subject, what you see is that our right hand side is positive. So since cosine theta is being equated to a positive number, we're only going to follow those quadrants in which the function cosine is positive. And those quadrants are the first quadrant and the fourth quadrant. We look at our restriction for theta. You can see that angles in all the quadrants are going to be accepted. But for this particular question, since we're looking at the cosine function, we're only going to concentrate on our first and fourth. Luckily in this question, unlike the first one we had, the fourth quadrant is being accepted as an answer. So what we're going to do here is just simply solve this. Theta is going to be equal to cosine inverse of 5 over 13. We get our calculator, we are finding cosine inverse of 5 over 13. That's our angle, 67.38. So our first answer for theta is going to be 67.38. Remember, our answers are supposed to be rounded off to 1 decimal place if they are angles that are inexact. So it will be 67.4 degrees. Then remember, the other positive value of the cos function is in the fourth quadrant. Therefore, we're going to find this angle 67.4 in the fourth quadrant. So we should note in this question the second theta is found by using 360 minus theta. So the second theta here, which I'm calling theta 2, is going to be 360 minus 67.38. I've just gotten the non-rounded off answer. Then if we calculate that, 360 minus our answer, instead of just using that, I use a more accurate one, so it's 292.61. I'm going to round it off to 1 decimal place, so it will just be 292.6. 292.6 degrees. This you should remember. You can show it in your working, there's no problem. You just need to remove that note and then indicate this as theta, and yeah, you can work it out like that. Here, I'm just going to write our answer. Theta is equal to that 67.4 and the 292.6 degrees. What I would advise you to do whenever you answer these trigonometric equations is use your calculator. Your calculator is with you in your exam room, and it's not a bad idea for you to test these values. So after you find, get your calculator. There's this equation that we are given, 13 cosine the angle that you have here. So you get the 67.4. Try it. You hit equals. Is my answer almost close to 5? Of course it is. It's 4.995. So if we round this answer using the 5, we get a 5 as our answer. You try it also with the other angle that you've gotten. So 13 cosine 292.6. You can see our answer there is still very close to 5. This is a simple thing that you can do to always know if you've gotten such questions wrong. The next question is from Mathematics Paper 2, 2018 GCE question 8. 3 villages A, B, and C are connected by straight paths as shown in the diagram below. Given that AB is 15 kilometers, angle ABC is 79 degrees, and the angle ACB is 40 degrees. Obviously, now we'll be asked questions. The first question we're asked is to calculate the distance AC. Look in the diagram and try to ask yourself which of the rules you're going to use to find distance AC. Is it the sine rule, cosine rule? Are we going to use the sum of interior angles anywhere? Or are we going to use the Pythagorean theorem anywhere? These are the 4 rules that mainly are manipulated when you're talking about triangles. Since usually in trigonometry, you're not talking about right-angled triangles, you're talking about triangles that have no 90 degrees in them. The Pythagorean theorem will be much less used. But if you've watched the videos about the sine rule or cosine rule, you will see that actually in forming the sine rule and cosine rule, there's a point where the Pythagorean theorem might have been used. Aside from that, let's look at this question and notice that we've got the angle opposite the side 15 kilometers and side AC that we've been asked to find the value for, or the distance between A and C, is the side opposite 79 degrees. So what you can see here is that this 40 is related to that 15, the 79 is related to side AC, and the rule that relates an angle and the side opposite that angle is basically the sine rule. Therefore, in the first question, we're using the sine rule to find the distance AC. So if we look at the diagram, we can form our sine rule. So sine C over the side opposite the angle at C is going to be equal to sine B and the side opposite the angle at B. Okay, the distance we want to find is the B here. So we're going to make B the subject, like I was just from explaining. When we've got this case in our equation, we can just simply swap this B and that sine C. And therefore, B over C is equal to sine B over sine C. Then we can make B the subject of the formula by just getting this C multiplied with that. There's no point in us multiplying this sine C with this B and then again dividing both sides by sine C. Therefore, this means that B is equal to C sine B divided by sine C. If we look in the diagram, C is the side which is 15 kilometers. And then sine B, B is the angle at B. and that angle is 79. And the angle at C is 40. And this is going to mean that B is going to be equal to a certain value, and we can calculate that value. We can say 15 sine 79 divided by, since there's an expression below there, there's a function, yeah, we're going to put the denominator in brackets, sine 40 like that, close our brackets that were opened here, then close those ones that we opened at first, then we hit equals. So B is equal to 22.9. Then you can again say 22.9. Remember, it's supposed to be correct to 3 significant figures, and this will be in kilometers. The next question is finding the area of triangle ABC, which is very easy. Sine A. If you calculate using the principle of the sum of the interior angles here, the angle at A can be found. So the angle BAC is equal to 180 minus 79 minus 40. 180 minus 79 minus 40. This gives us 61. So this is the angle at A, and now we can use this. So we said area is equal to half. The side B is the one opposite 79 degrees, and we calculated the value AC, if you can remember, it was 22.9. If you want, you can say 0.7, there's no problem, but just remember to keep your answers as accurate as possible. The side C is the one opposite 40 degrees, which is 15. Then now we're finding sine 61. We use the calculator to find the area. Okay, yeah, 22.907 multiplied by 15, and since there's just the sign, we can just start writing sine 61. Our calculator will always multiply sine of a certain angle with a number that's in front of it. Equals, we divide by 2, and that's our answer, 150.261. Notice that if we end our answer on 1, we're supposed to round off with the 8, therefore it will be 150.262. 150.262. This is supposed to be in kilometers, and we should add that small squared, which is square, which makes the units square kilometers. Then we round this off to 2 significant figures. Yeah, it will be like that, 150. And we're going to write it like that. Once again, we're asked to find the shortest distance. So we have the distance AC, which is going to be our base. Now we don't even need to worry so much, we just need to go direct this time. So H is equal to 2A over B. B for base, A for area. Area we just found, and so it's going to be 2 multiplied by our area, 150. We can get the one that we rounded off with more numbers, this one here, 150.262. Then our base is side AC, which we calculated. It was 22.907. We punch this in a calculator and we have our shortest distance from B to AC. 2 multiplied by 150.262 divided by 22.0 0.907. That's 13.11. It's going to be in kilometers. This is a distance, and we have answered this question. In the next question, we're asked to solve the equation cos theta is equal to 0.937 for a value of theta that is between 0 degrees and 360 degrees. Since this is the cosine function, we know that the values of theta that we're going to accept are those that are between 0 and 90 degrees, or in the first quadrant, and those that are between 270 and 360 degrees, or simply in the fourth quadrant. So we're going to find cosine inverse of what's on our right hand side, which is 0.937. Therefore theta is going to be equal to cosine inverse of 0.937. If we punch this value on our calculator, we should get an answer 20.44, about that. As you can see, it's 20.446. There are other values there, so we can need it on the 6. So we have a 6 here, degrees. Then we need to note that we need to find the second value of theta, or another theta that can give us this answer. That theta is going to be in the fourth quadrant, where we can use this simple expression 360 minus theta to get the value of the theta that can give us 0.937 also. Our value of theta that we earlier found in the first quadrant is 20.446. There are other values, but this will be fine. Then we evaluate that. The value of theta 2 is going to be 360 minus 20.446, which is 339.554. 339.554 degrees. So this, you should note how we got our second theta. In your working in the exam, you can add it to your working just as a step. After you find this theta here, you say theta 2 is equal to 360 minus theta. But here I just want you to note how we got it, because I'm just going to say theta is going to be equal to 20.4 degrees, and it's also going to be equal to 339.6. So you know how we got our second value for theta. It's written there. The next question here asks us to sketch the graph of y is equal to sine theta. Sketching your graphs in Mathematics Paper 2 is not very difficult. What you just need to always remember is a simple procedure. You need to simply draw this here. This is basically a graph. We have our y-axis and our x-axis. Our y-axis is going to bear values. This point here is going to be 0. Then we're going to find a point above here that we're going to write as 1. Then we also need a -1. Our sine graph, or the graph of y is equal to sine theta, is going to start from 0. And what you need to always remember is that our sine function looks simply like this. So we just need to know how to get this point here, this point here, this point here, and this point here. If you know that, you're home and dry. Okay, now here we've got 0. This 0 here indicates a 0 value on our x-axis and a 0 value on our y-axis. On our x-axis, we're going to have angles. So from this 0 here, we're going to have a 90, and this will be 90 degrees. After the 90, we're going to have 180. After the 180, we're going to have 270. Notice they've told us for 0 degrees up to 360. So the last number here is going to be 360. Our graph can keep going over and over and over again. But yeah, for this question, they've told us we're going to end on 360. Now remember, our shape for the sine graph looks like this. This point here is 0, 0. So it's going to be this point here. This point is 90 degrees, 1. So it's going to be there. And we just keep following these points until they look like this graph here. The next one is going to be 270, and it's going to be -1. Then the last one is going to be on 360. So what remains here is just joining these points that we've made and making it look very smooth. So this is our sine graph. And whenever you draw a graph here, it's very important that you label it. You can just simply say y is equal to sine theta. And you've answered this question. You've sketched the graph of y is equal to sine theta. This is how it looks. There are many other graphs. For example, you should know how y is equal to cosine theta looks, and even how y is equal to tan theta looks like. The next question is a Mathematics Paper 2, 2016 question 10. The diagram below shows the location of 3 secondary schools, namely Kamuvala, which is symbolized by K, Belengani, which is symbolized by B, and Pendeni with the letter P. These 3 secondary schools are in a particular district. P is 5 kilometers from K. You can see P is 5 kilometers from K. B is 3 kilometers from K. You can see the distance there. And then the PKB, which is an angle shown there, PKB. Let's begin answering this question by calculating the distance BP. Of the 3 methods that we've been using here, the sums of interior angles, sine rule and cosine, this time we're going to be using the cosine rule. You can see that we've got 2 sides and the angle between those 2 sides. Therefore, we can use the cosine rule. The side opposite the angle at K is going to be a lowercase k. The side opposite the angle at B is going to be B. The side opposite the angle at P is going to be a lowercase p. So instead of a squared, it's going to be k squared is equal to b squared, which is b. We have a b there, so there's no problem. And then c, we don't have a c, instead we've got a p. So it is going to be p squared minus 2 bp cos k. This is how we're going to change our cosine rule, and we'll just plug in values into this formula, and then we'll have the value of k squared. If we look in our diagram, now we know that k squared is going to be equal to b squared. B is 5, while p is 3. We have a 5, a 3, and cos 110. We can simplify some parts here, but yeah, it's better for us to just go to the calculator and do it once and for all. We can just write it as it looks. then we close our brackets for this bracket that was open, we hit equals. This is our value that is equal to k squared. Remember, I insisted on saying we're going to find the value for k squared and not k, because it's a very common pitfall for students. We have k squared here, and so that 44.261 we found. Now, to get rid of this square here, we're going to find the square root of both sides, and then k is going to be equal to plus or minus the square root of this, but since we're looking at the distance, it's just going to be equal to the positive value of square root 44.261. We have the whole answer here, but yeah, we can just continue with how we wrote it here, 44.261, which gives us 6.65. We can round off using the 8 there, then round off to the required number of significant figures. Therefore, k, as we saw, is going to be 6.65. There are more numbers, but yeah, we can end on the 4. Rounding off to the required significant figures, we're going to have 6.65 kilometers. So this is the distance BP. Next, we're asked to find the area of triangle BKP. In this question, we already have our values organized well enough. We've got two sides and an angle between those two sides. If you look in the diagram, we've got side BK and we've got side KB. We also have the angle at K. Therefore, area is going to be half the side B and the side P sine the angle between these two sides, which is the angle at K. B is 5, P is 3, and we're going to be finding sine of 110 degrees. We divide by 2, and that is our area, 7.0476. We can round off with the 8 that followed the 6, and then round off to 3 significant figures, which gives us this number here. You remember, it's supposed to be in square kilometers. So this is our area. The next question asks us to find the shortest distance from K to BP. If you look in the diagram, we have not been given distance BP. But if we look at our solutions that we just found earlier, we found the value of BP. So if you didn't find BP in this exam, you couldn't find the shortest distance because BP is our base. And we know that for us to find the shortest distance, which is just the height, we use this simple formula: H is equal to 2A divided by B. B being the base or the side to which the shortest distance will touch. The shortest distance is from K to BP, and the side that we have between this information that we've been given in the question is that our side is BP. So we're going to use the area that we calculated, 7.0, I think we can use the 477, then multiply it by 2. After that, get our base. Our base is BP, the distance that we earlier calculated. You can remember it was 6.65. If you want some accuracy, we can add the 4 like that, then punch this on the calculator and find the value. Okay, we have 7.0477 multiplied by 2 divided by 6.65 That is our answer, 2.118. This is the shortest distance. This is in kilometers, and we can round this off to 3 significant figures, which gives us 2.12 kilometers. The next question here asks us to solve a trigonometric equation. This time we've got the function tangent theta, and it's equal to 0.7. The question you have to ask yourself here is, when I look at the quadrants, I've got all trigonometric functions positive in the first quadrant. In the third one, we've got tan, which is positive. In the fourth, we've got cosine. Very important to remember your angles here. And we've got 180 degrees, 270 degrees here. So in this question, we have positive values for tan theta only exist if theta is between 0 degrees and 90 degrees, or theta is equal to an angle between 180 degrees and 270 degrees. Now, if we look at the restriction we've been given, theta should be between 0 and 180 degrees. It means the value of tan theta, which is also positive in the third quadrant, is not being considered. Therefore, the answer that we're only going to have is the answer in the first quadrant. Tan theta is equal to 0.7. Theta is going to be equal to tan inverse of 0.7. We're going to have our calculator help us with finding the value of theta. Shift to hit the button that's labeled tan 0.7, and we have our theta. We had 34.99. We round this off to 1 decimal place. The next question is from Mathematics Paper 2 2017 GCE question 10. In the triangle PQR below, QR is 36.5 meters, angle PQR is 36 degrees, and angle QPR is 46 degrees. You can look at the diagram and just have an idea of what we're going to do. If you ask yourself the question I've just told you to be always asking yourself when you're answering trigonometric questions, obviously you're going to see that the best way for us to calculate PQ is first find the angle at R and then use the sine rule to find the distance PQ. We're going to use the principle of the sum of the interior angles to find the angle at R, and then after we found the angle at R, we can simply use the sine rule to find the distance PQ. What I would like you to do is pause the video and try to do this question on your own, and then see if the answers that are going to be found here are going to match with yours. Using the diagram, we can label the angle at R as PRQ, and it can be gotten if we subtract the other angles from 180, which are PQR and QPR. PQR is 36 degrees, while QPR is 46. Our angle at R is 98 degrees. This is not our final answer, it's just going to help us use the sine rule. Using our sine rule, it's very easy for you to come about with this equation. Sine p, the angle at p divided by the side opposite the angle at p is equal to sine of the angle at r divided by the side opposite the angle at r. Sometimes it's a bit better if you are finding a side that you put these small or lowercase letters on top. What I mean is, instead of writing it like this, you can write it as p sine p like that is equal to r sine r. Or if you don't mind, always just remember one of these forms and then make whatever you want to find the subject. However, when you're finding a side, it's better that you use this form of the sine rule, because it will enable you just to get this sine r multiplied by the p, and you already have r as your subject. For this question, I want you to be able to use this form, making r the subject, the lowercase r there. R is going to be equal to p sine r divided by sine p. And we can continue. We've got the distance p, which is 36.5. We've got the angle at r, which we just calculated as 98. And we've got the angle at p, which is 46. So it's going to be sine 46. Therefore, r is going to be the value of this here after we punch it on the calculator. We've got 36.5 sine 98. You can hit equals, then divide by our expression in the denominator. Notice we're supposed to put it in brackets. This will just prevent you from making any mistakes. R is 50. Correct to three significant figures, it's 50.2. In this exam question, again, we're asked to find the area of a triangle. What I want you to pick from these questions we've done in this video is that make sure as you are going to write your paper 2 exam, you know how to calculate the area of a triangle that is not a right angle triangle, and you can find the shortest distance. These are things that always are examined. When finding the area of triangle PQR, we're going to ask ourselves a simple question: are there any two sides that we know? And we've got the angle between those two sides. If you can remember, we found the distance of PQ. And because we have the distance PQ, the distance RQ, and the angle between these two distances, we can use them to find the area of triangle PQR. Sine the angle between these two, which is the angle at Q. The distance R is distance PQ, which we earlier calculated. It was 50.2. You can write it up to maybe the 7. The distance P we have is 36.5. And the angle at point Q we have is 36. We still have our distance there. We can just multiply it with the 36.5 and sine 36. And we divide it by 2. we can write our answer correct to 3 significant figures. It's going to be 539 square meters. Next, we find the shortest distance from R to PQ. Whenever we're asked to find the shortest distance, like I said, we just remember this simple equation. H is equal to 2A over B. B is going to be the side that we've been told to find the shortest distance to, and that side is PQ. And then A is our area. PQ was 50.2. We find the value of this, and then we have our shortest distance. So our shortest distance is 21.454. Rounded off to 3 significant figures, this is going to be 21.5. Always remember to include your units. Next, we are asked to solve the equation sin theta is equal to 0.6792 for theta, which is between 0 degrees and 360. Whenever we have sine, we know we're going to have 2 values usually, because sine is positive both in the first quadrant and in the second quadrant. Theta is going to be equal to sine inverse 0.6792. This will be the angle in the first quadrant. Shift and we hit the sine button. This is our theta in the first quadrant, 42.7811. Then we need to find the second theta. This is how you can write it if you want it to be in continuation. And then we can find the value of 180 minus 42.781, which is 137.219. So our solutions are equal to 42.8 degrees and 137 degrees, 137.2 degrees. These are our solutions. In the last question, we're going to be looking at Mathematics Paper 2 2016 GCE question 7. 3 towns, Luzi, Muzi, and Puzi, are spaced as shown in the diagram below. Luzi is represented by L, Muzi is represented by M, and Puzi is represented by P. One thing worth noticing in this question is that our angles are given as bearings. That's not a very big deal. You can easily work them out and find the values of the angles inside the triangle. We've been given that M is 450 kilometers from L and 600 kilometers from P. Then we've been asked to calculate some distances, obviously. The first distance we're calculating is the distance between L and P. To calculate the distance between L and P, we must find the angle here at M. And how are we going to do that? Well, to calculate this angle at M, we're going to do something very simple. We know that these two lines here that have been represented as N are parallel to each other. And then this angle here, 60 degrees, plus the angle here is going to give us 180. What simply I want you to pick out from this that I have pointed out is we've got two parallel lines that are running like that. These are the northings. Then we've got the 60 degrees here. We know some relationships between the transverse and parallel lines. This angle here and the angle here added together are equal to 180. So what I want you to get from the diagram here is the point at M. So we've got the point M, we've got this representation here. The angle here is 105. And then we know we can find the angle here. We've got another northing here. We've got 60 degrees. So we know that, let's say the angle A here can be found very easily. A plus 60 degrees is supposed to give us 180 degrees. Therefore, A is going to be equal to 180 minus 60. If we do the calculation there, A is supposed to be 120 degrees. Now, we also know that if we add 105, the 105 there, plus A, and plus, let's say, an angle here, which is B, we're going to have 360 degrees. We've already calculated the value of A, so B is going to be equal to 360 minus 105 minus the value of A that we just calculated, which is 120. The value for B gives us 135. So we have found the internal angle there for the triangle. It's 135. Just for you to be able to easily revise, let me make this diagram a bit bigger. Now, since we have the value of the angle at M, or the B that we were calculating just now, we can easily find the length of the side LP, or as they've termed it, the distance between L and P. To find that distance, we're going to use the cosine rule. The side opposite this 135 is going to have a lowercase m, so m squared is going to be equal to L squared plus P squared minus 2LP cos the angle at M. Then we're going to substitute the values that we have, the value of L, P, and the value of the angle at M. Notice, for this question, the main difficult manipulation that they made was you realizing that you need to use the internal angle of a triangle, or interior angle of a triangle. The distance L is 600. We're going to square it. The distance P is the distance opposite the angle at P. That distance is 450. Going to square it. 2, we have an L there, a P, which is 450, and cos M, the angle at M, which we just found as 135. Okay, now remember we've got an m squared here, so whatever value we're going to get on our right side is going to be equal to m squared. 600 squared plus 450 squared minus 2, you can just copy it as it is, the brackets there, 450, we close the brackets, then cos 135. Notice there was a bracket opened automatically, then we hit equals. This is our value, 944,337.6. 337, we had 66. Then we need to get rid of this square here. That just simply means applying the square root on both sides. That square root and the square there cancel themselves, and therefore this m is going to be equal to the square root of this answer here. So we just say square root of answer instead of starting to type all those numbers. But yeah, if you want, you can say square root 944,337.66. That gives us 971.77. And this is in kilometers. What we can do here, because of space, is we're just going to write it as a number already rounded off. The three significant figures we're rounding off with this 7, so here we're going to have a 2, so it will be 972 kilometers to three significant figures. Now the next question asks us to find the area of the triangle LMP. Since we have got two sides and the angle between those two sides, this question is straightforward. We're not going to do any of calculations, we're just going to plug in things. We've got the two distances P and L, so we can say half PL sine M, which is the angle at M, and this angle M is between the sides L and P. P is 450, L is 600. Put a bracket there, then we've got sine 135. We find the value of this and find our area. The 450 multiplied by 600 sine 135. We divide this by 2, and that's our area. 95,459.4. 95,459.4. We're going to round this off to three significant figures. Here we're going to have a 5 and 2 zeros like that. Remember, this is in kilometers, so it will be 95,500 square kilometers. The last question asks us to find the angle MPL. If you look at angle MPL, they are talking about the angle at P. So what we're going to do here is look at what we've been given. Which are we going to use, cosine or sine rule? Obviously, after you spend some time looking at this question, you'll find that using the sine rule will be kind of a much easier approach. Why? Because we have the angle at M, we've got the side opposite the angle at M, which is distance LP. We have the side which is opposite the angle at P. Therefore, if we use our sine rule, notice this time we're finding an angle, so we can keep the sine on top. Sine the angle at P, which we are finding, divided by the side opposite the angle at P, which is a lowercase p, is equal to sine the angle at M over the side that is opposite the angle at M, which is M. We've got M, we've got this uppercase M, which is the angle at M, and we've got P. Therefore, we're just going to make P the subject of the formula here. You agree with me after you make P the subject of the formula that P is going to be equal to sine inverse this big fraction here, p sine m over m. So immediately we plug this into our calculator, we're going to have our answer. You can work with it bit by bit, there's no problem. But here you can also see how we can work it out as just one whole thing. P is 450. Then we've got sine m. M is the angle that we earlier calculated in this question, 135. The m is the distance LP that we calculated. I'm going to use the one we didn't round off, 971.77. And then we get our calculator and see the value that it's going to give us. 450 sine 135 equals, then you divide that answer by 971.77. This gives us 0.3271, an answer that we expect if we're finding an inverse of sine. Then we find sine inverse, shift the sine button, and then our answer that we're just from finding, hit equals, and there's our value, 19.11. Our angles are supposed to be correct to 1 decimal place, so our answer is going to be 19.1 degrees. These are some helpful questions that you can use to revise trigonometry fully. You have finally reached the bonus tip section. In today's video, we've got 4 tips for you. The first is how you can remember the cosine rule. If you really pay particular attention to the cosine rule, you can see that there's the Pythagorean theorem just in this rule. Here we've got a squared, b squared, and c squared. One thing that I would like you to point out here is this is just our alphabet. This is a, this is b, this is c. So the first part of the cosine rule is just your alphabet. You should always remember that the letters of the alphabet are going to have squares with them. There will be a squared, b squared, c squared. After that, you're going to introduce this minus here. And then after that, we're going to have a 2 multiplied by bc. If you pay close attention, these 2 letters here are actually the letters here. However, this time we do not square them. After that, we have our cosine here, and then we're finding the cosine of the angle with a letter the same as this first letter that we had here. To get a feel of how this might change, let's look at this other one. Here we've got b squared. What changes here? Since a triangle has got 3 sides, when we use b, the only other letters that we can use are a and c. Therefore, the cosine rule changes, as you can see. One thing you note is that still here, we've got the cosine of the angle with the same letter as the first letter that we used here. Notice how it changes when we use c. With this simple trick, you can easily remember the cosine rule. The best way to remember it is using this one here where we've got A, B, C, because we've been looking at the alphabet since kindergarten. Now let's look at the second tip. In the second tip, we want to see how we can graph the cosine function, or basically how the graph of the cosine function looks like. One thing that you need to point out or remember when you want to graph the cosine function is the value of cosine 0. Cosine 0 is 1. So if you can remember that simple fact, you remember that your graph is going to start from here, and then the rest of the graph is just going to be dropping. It's going to utilize 1, 0, and -1. So if our first point is here, the next one is going to be on 90, the next one is going to be on 180, and it's going to have -1 like that. And then the third one is going to be 270, back to the 0, 360, back to the 1. If we join those points, our cosine graph is going to look like this. Now, let's talk about the third tip, which is about how we can graph the tangent function. The tangent function is not as simple as graphing the other functions that we have. It's very different from the sine graph and the cosine graph. However, if we were to go into detailed structure of this function, we could see that the tangent function actually is related to the sine and cosine graphs. However, let's leave that for another video. What I want you to realize here is that we've got dashed lines. These dashed lines are known as asymptotes. Whenever we have these dashed lines on a graph, usually our graph that we're going to draw is not going to cut through them. As you can see here, our graph starts kind of curving and it won't touch. If we were to extend these lines, they will look something like this. This is the full form of the tangent function. Obviously, it looks better and you can even understand it clearly, right? Yes, now in your exam, you won't have so much space. If this was to come, you just get something like this. In summary, what you're supposed to do is first locate the points where these dashed lines are going to be. If you notice with me carefully, they are in the points where 90 is multiplied by an odd number. For example, here it's 90 times 1. The next odd number is 3. So this is 90 times 3. The next one is 5. 90 times 5 is 450. After you have decided where dashed lines are going to be, you now need to locate the points in between these dashed lines. As you can see here, we've got a 90 and a 270. The point in between these two is 180. These points that are in between the dashed lines are the points where our graphs for the tangent function are going to cross the x-axis. So when you have those dealt with, you're almost done with your tangent function. The only thing you need to do is now drawing this curvature in between these two dashed lines. Now, how can you estimate how this curvature is going to go? Making use of nice estimations. Here we estimated that the point is going to be in between the dashed lines. Then now we estimate a point in between 0 and 90. So you come in between 90 and 0, try to draw a line vertically like that, and then try to draw another one horizontally like this. Then the point here where these two lines coincide is going to help you graph. You do the same for here. You try to estimate the point in between the 90 and the 0, come down like that, find the 1, and this point will help you have an overall idea of how this graph is going to be sketched. Tip 4 is about trigonometric equations with negatives. How do we deal with them? Well, they're not very complex. You just need to remember one fact. Whenever you have a trigonometric equation with a negative, it simply indicates to you that the answers that you're supposed to give are supposed to be those where that trigonometric function is negative. What do we mean? Let's look at the equation for us to understand it better. We've been given this trigonometric equation, 5 sine theta plus 2 is equal to 0. We've been asked to solve this equation for values of theta that are going to be in between 0 degrees and 360 degrees. If we write this equation like this, we make 5 sine theta the subject, we're going to have this equation. You can see we have a negative, unlike others that we've looked at in this video. This negative is pointing to us the values of theta that we should use are supposed to be those in the quadrants where sine is negative. So basically we're doing the same thing. We're going to divide both sides by 5 so that we can have sine theta as our subject. Then we're going to find the inverse of what's on the right hand side. This is the point where you need to be careful. We're not going to find the inverse of sine negative 2 divided by 5. We're only going to find sine inverse of 2 over 5. Like I pointed out earlier, this negative is just indicating to us that the values of theta that we're supposed to use or give as our answers are supposed to be those in the quadrants where sine is negative. You can see that sine is negative when theta is from 180 degrees to 360 degrees. That means sine is negative in the third and fourth quadrant. Therefore, the value that we find here, which is 23.58, you can get your calculator and verify that, is not our final answer. We need to find this angle in the third and fourth quadrant. This angle that we have here is going to be 203.58 in our third quadrant, and it's going to be 336.42 degrees in our fourth quadrant. Basically, you should have an idea of doing this mathematics. If it's not so easy for you to understand this fourth tip, try checking our videos that explain trigonometry on the Cartesian plane. Thanks for watching this video till the end. Make sure you check the description for the downloadable PDF for the answers that were written in this video.